Hello class, this is the second video covering section 2.2. In the last video we solved a nonlinear equation numerically, meaning we looked at the table and we were able to come up with solutions, right? So if I wanted to know the value of x that would give me negative 12, I'd go to negative 12 and find x. And so in this case the answer was x equals negative 2. So we solved equations numerically, now we're going to try to do it graphically. So for example, if I were to ask you to solve this equation for x, I'm asking you what value of x would give me 8. The way you'd handle this would be draw a line at y equals 8 and look for the intersection. So you can see we have two intersection points here, right? One's here, that looks like x equals negative 1, and we have an intersection here, looks like x equals 5. Right, so your answer would be x equals negative 1 and x equals 5, right? Look at this next problem, right? What value of x would give me negative 1? So I'm going to draw a line at negative 1. Let's get my tool out here, and somewhere around here. And you notice that our intersection, it only intersects one time, so we have one solution, right? It looks like x equals 2. Right, and you can see they wrote the answer x equals 2. Right, so we could have two solutions, right, such as the first problem. We could have one solution, but take a look at letter D. This is a situation where we might have no solutions. Okay, what value of x is going to give me negative 2? Let's just scroll up a little bit. All right, so the value of x that's going to give me negative 2, well, I have to draw a line at negative 2. So that's down here. Notice there's no intersection, right? This purple line does not intersect with my graph, so the answer is no solution, right? There is no value of x that's going to give me negative 2, all right? So you'll notice how they wrote no solution, okay? Let's take a look at the next page. All right, a couple of more nonlinear. Right, nonlinear just means it's not a straight line, right? You see there's a curve here, we have some curves. So for something like this, we're not going to do all of them, but if I were to ask you to solve this equation for x, what value of x is going to give me 1, I can draw a line at 1, and you see my intersection is right here. So it looks like the value of x would be 0, right? This is 0, 2, 4, 6, 8. So my answer would be x equals 0, right? So for letter A, let's see if I can erase this. I got a little crazy here. Erase. Ooh, didn't want to do that. Let's try something else. Here we go. That's better. Ooh, even that was too much. Let's try one more time. All right, there we go. So the solution, what value of x is going to give me 1? The answer would be x equals 0, right? Because that's where the intersection happened, at 0. Okay. Here's the one where we have to estimate the solution. All right. So what value of x will give me 0? So I'm going to draw a line at y equals 0, right? And the intersection looks like it's in between 0 and negative 2. So maybe I would say negative x equals negative 1, right? X equals negative 1, right? This intersection looks like it's in between negative 2 and 0, so negative 1 is right in the middle. Okay? If you look at letter C, I draw a horizontal line at negative 2. Notice there's no intersection, so my answer would be no solution. And then the last one, if y is 3, what is x? So I draw a line at 3, and it looks like it intersects over here. So the answer would be x equals 8. X equals 8. That's it, right? You can do the same treatment, whoops, even though the curve looks different, the solution, finding the solution is the same, right? If I were to say, what's the value of x? It's going to give me negative 12. I would draw a line at -12, horizontal. The intersection looks like it happens at what? -2. So my solution would be x equals -2, right? X equals -2. So that's a situation where there's only one solution because there's one intersection. But if you look at letter B, right, when we're trying to find the value of x when y equals 0, I draw my line at y equals 0, and you notice we intersect 3 times, right? Once, twice, 3 times. So it looks like -1, 1, and 2 are my answers, right? X equals -1, x equals 1, x equals 2 are all my answers, okay? So I hope that helps. The next thing we want to do is look at solving linear equations with parentheses symbolically. And they give us a few steps. So you might want to pause the video to review steps 1 through 4, right? It says step 1, use the distributive property to remove the parentheses, combine like terms, move the constant term to one side by addition or subtraction, move the coefficient to the other side by multiplication or division. So let's put this into practice. Looks like they've actually done the work for us. Right, so if I want to solve 2 times x plus 1 equals 18, the first thing I want to do is use the distributive property to get rid of the parentheses, right? So 2 times x, 2 times 1, right? Then I want to get the x's to one side and the numbers to one side, so I can subtract -2 from both sides, right? -2 from both sides to get 16, and then divide both sides by 2 to get 8, right? And then you can always check your work, right? If I take this 8 and put it back into the original equation, do I get 18? If I do, I know it worked, okay? So that's an example. They give us another example, right? Same thing. Use the distributive property right away to get rid of the parentheses. Then combine like terms. Use addition or subtraction to get the constants to one side, right? So here I'd have to add 5 to both sides and then divide both sides by 3 to get my answer. Okay, so let's try a practice problem on the next page. Looks like we have a couple of problems. So I'm going to start with number 15, okay? And then I'll do one more video where I answer a couple more of these problems. So 15, I'll rewrite it up here just so I have some more room, right? So we have y minus 3 times y plus 1 equals 7. I'm going to distribute the -3 all the way through. So I now have y minus 3y minus 3, because it's -3 times 1. And then I combine like terms. So I have a y and a -3y becomes -2y, right? I combine these. Minus 3 equals 7. Then I add 3 to both sides. So I'm left with 2y, and it's negative, equals 10. Whoa, let's get that, let's clean that up. Equals 10. And then I divide both sides by -2, right, to get y equals -5. Okay? So I'll just take a moment to review my work, because I'm going to erase this for my next video, and I want to answer a few more problems. Okay? Thank you for watching.